Hi, it's Mrs. Pope, and today we're going to talk about compound inequalities. Our goal today is to solve and graph compound inequalities. We have and versus or. So we're going to look at two different scenarios, and compound inequalities, or compound inequalities. So before we get into the actual graphing of the inequalities, I want to talk a little bit about the concept of and versus or. If you have two sets here, we have colors. These are all colors, of course. Then these are all fruits. So if we look at these two sets individually, we have a bunch of colors and a bunch of fruits. The intersection, an orange is a color and it's a fruit. And a tangerine is a color and it's a fruit. I did have to verify this. I looked in our crayon box at home, and tangerine, according to Crayola at least, is indeed a color. So here we talk about the intersection. If I'm talking about and, I want to know what's a color and a fruit. So that's the intersection. Think of and as intersection. So this includes the intersection of the two sets. The or, I'm talking about color or fruit. I don't care if it's a color or a fruit, I want to include them all. So this includes all of both sets individually. So I have all of my color and all of my fruit. So or is going to include all of those because I don't mind which one it is as long as it's one or the other. So and intersection, or is going to include all of them. So let's look at some examples. Example 1 says solve and graph and compound inequality. So we have 8 is less than 3y minus 7, which is less than or equal to 23. The reason it's a compound inequality, it's not just a simple one, is because we have two different inequality signs. So we have, actually, if you think of this, normally with an equation or a regular inequality, you have the left side and the right side. So if you do whatever you do to the left, you have to do to the right. Well, now we have three sides. So we have the left, the middle, and the right. So whatever we do to solve this, we're going to have to do to all three of these sides. So here, I'm trying to solve for y, and then that's what we're going to be graphing. So I want to get rid of 7, get rid of the 3, just like you would a regular equation, except for we have to do it on all three sides. So the first thing I want to do is get rid of the 7. So I would need to add 7 to all three sides. Once you do that, you have 15 less than, these cancel out, 3y, which is less than or equal to 30. Last step, I need to get y by itself, so divide by 3, divide by 3, divide by 3. You have to do everything. Here, we're going to be left with 5 is less than y, which is less than or equal to 10. So here's what we're actually graphing. I'll write it over here so you can see it a little better. This is the compound inequality that we're graphing. So we want to graph where y is between, it's physically between 5 and 10. Y is greater than 5, but y is less than or equal to 10. So we're going to go to our number line, and we need to plot 5 and 10. So here, I have 5 would be here, and it's going to be an open circle because there's no line underneath. Go to 10, it's going to be a closed circle, and I want to shade between them because y is between them. So this is and. This is when y is greater than 5 and it's less than 10. So if I just looked at greater than 5, that would be the entire side, this entire side of the number line. If I just looked at less than 10, that would be all the way down here. I don't want that. I want both of them when they intersect. So that's the intersection here. All right, let's look at the next example. Example 2, negative 12 less than or equal to 4x plus 8, which is less than or equal to 32. So we want to get x by itself. We need to first subtract 8 from all three sides. Negative 12 minus 8, negative 20, less than or equal to 4x, which is less than or equal to. And make sure here, like I said, when you're doing all three sides, you want to make sure you're doing the same thing. So make sure you keep your minus sign with you as well so you don't get confused. All right, so negative 20 less than or equal to 4x, which is less than or equal to 24. All right, so now I need to get rid of the 4. Divide by 4, divide by 4, divide by 4. Negative 5 less than or equal to x, which is less than or equal to 6. All right, so now I need to graph where x is between negative 5 and 6. So I'm going to go over here to negative 5. I have a closed circle. go to 6, I have a closed circle, and I want to graph or shade where x is between these two numbers. So this is and. It's this and that. They're both included. It's the intersection of these two if they were written separately. Like I was saying, this is actually, if I wrote these separately, x is greater than or equal to -5, and x is less than or equal to 6. These two separately, we just join them together by putting x in the middle. But if you graph these two separately, you would see if x was greater than -5, it would be everything to the right of -5. And if you graph less than 6, it'd be everything to the left of 6. But we want the intersection where both of those two things are indeed true. All right, let's look at 2 more examples. So example 3, solve and graph. These are or. So now we have or here, and it'll tell you or. We want this or that. Simple one-step equation here. We want to subtract k plus 6 minus 6 less than or equal to -4 minus 6. So k is less than -10, or divide by 3, that's a k, is greater than or equal to. Again, you can leave it as 14/3. I would turn it into a decimal if I were you. It's a little easier to graph. So I would say k is greater than or equal to 4.6, repeating. So graphing, k is less than -10. So we're going to go to -10, open circle, less than. That's everything to the left. Everything to the left. Or it's greater than 4.6. So 4.6, let's say that's about here, greater than or equal to. So notice they're going in opposite directions. Or it could be all of this, or it could be all of that. They never intersect, so it can't be when both of them are true. It can't be and, there's no intersection. So it's either this one or that one. Both of them are part of the solution. All right, last example. M minus 7 greater than or equal to -3, or -2m plus 1 greater than or equal to 11. We want to solve these. So m minus 7 plus 7 greater than or equal to -3 plus 7. M is greater than or equal to 4, or we're going to have -2m plus 1 minus 1 greater than or equal to 11 minus 1. Subtract 1 from both sides. -2m greater than or equal to 10. Divide by -2, divide by -2. M is greater than or equal to -5. Graph these two. M is greater than or equal to 4. We're going to go to 4, and we have a closed circle, and we're going to graph all the way here. Let's see, did I do that right? M is greater than or equal to -5. So we have -5, and we have greater than or equal to -5. So this one actually includes everything from -5 all the way to infinity. That's when we have both of them, and both of them are true statements. Thanks for watching, and remember, you are responsible for your own learning.